this test. This 2023 making this. We'll see. Here we go. So possible solutions here. We're going to shade this. So we're going to start off at 1. It's going to be hard here, but it's going to go up 4 and over 1. So I'm going to count up 4 and over 1 from that y-intercept. We have ourselves a dotted line. Less ink makes a dotted line. It's greater, so greater is going to be on this side over here. All right, it's above the line. And then the other one, my suggestion is to solve for y. We did this in the homework. We only, when we solved it for this y, bring the 3x across, divide by 4. So it's negative 3/4 x. And we divide that also by 4. So it's going to become 3. We only flip the inequality, though, when you divide by a negative. Since I divided by a positive 4, the inequality did not flip. Okay, so it's starting at 3. 1, 2, 3, and let's use a different color here. 3, and then it's going to go down. It's a negative slope, so it's going to go down 3 and over 4. I apologize if I'm off, but I think it's on there. It's a full line because it has more ink. It has a line underneath there. It is less than this line, so we've got boom. And so it's where they both are shaded. So it's like this red area. So where both of them are shaded. And then asking for solutions, 3 possible solutions on your test. So like any order pair that's inside here, so you just got to be able to make sure that you have the correct order pair. Remember, it goes x, y. So like if I said negative 5, comma 2, which is over here, that's about yay. That's one of the possible solutions. Anything that's in this shaded region is okay. Substitution, they're equivalent. Y is equivalent to 4x plus 3, so I'm going to replace the y with 4x plus 3. So when I do this, make sure that I put this in parentheses. I'm going to put a 1 there. You don't have to put the 1, but good mental mindset. And distribute the negative 1. So now I've got 5x minus 4x. It's going to be minus 3. That negative distributed all the way to the 3 equals 2. And if I solve this like terms, so x minus 3 equals 2. X is 5. That's only half my value. I need the order pair. So 5 is the x. Go back and plug it into one of the equations. The top one's the easiest one here. So 4 times 5 plus 3, which is 23. So 5 comma 23 is your order pair. Combination, we're going to get rid of the x's and we'll get rid of the y's. Don't be afraid if they are fractions like this one is. Since 4 and 5 have nothing in common, it's just easy enough to go ahead and take the 5 to the top one, the 4 to the bottom one. Now, currently this is going to be 20x and 20x on the bottom. We need one of them to be negative, so I'll choose the top one. It does not matter which one it is. I could totally choose the bottom one. Let's do the bottom one. As I'm doing this, it'll make it so I don't have a negative there. So distribute. So it didn't matter which one, so I chose the top one to be positive this time. So it's 20x, 15y equals 80, negative 20x, and 8y, positive 8y, because it's a negative times a negative, which is positive, and then negative 8. And so these cancel out. And yes, you could check this easily with the RREF to figure out what the answer should be. And if you do math fraction, when you do the RREF, because it's going to be 72 over 23, which is a wacky decimal, that's half our answer. Okay, so 72 over 23. And then if I do this again, this time I'm going to get rid of the y's. So 2 goes here and the 3 goes here. Again, I did not include a negative because I already have a negative. So if I do that math, I'm going to get 8x plus 6y equals 32. 15x negative 6y equals 6. And so this is 23x. So x is 38 over 23. That's the x and the y. Okay, number 4, either way. So we already have y equals, so then that lends itself to substitution. So I'm going to go and do substitution. So 5x. There's a 1 that goes in front of the y. It's plus, so I don't need the parentheses. That's okay if I did have them, but I don't need them. And that green is hard to see. So 7x, solve this. Oops. Solve this, you're going to get 28 on the other side. X then is 4, because 28 divided by 7 is 4. Go back, plug it in, and so you get to y here is going to be 11 on that. All right, next one. Either way, y equals 4x plus 3. This is going to end up being a lie, because everything's going to cancel out. So you get 2. When it's a lie like this, that means it's a no solution. So these are going to distribute. I get 8x plus 6. Like this, like so. Is cancel, so I get 6, which is not equal to 10. So it does not equal, right? So it's that no solution. It's a null set on that. Okay, next one. So writing a system that has a solution, you can choose any which way to do this. You can either do standard form, or you could do slope-intercept form. Standard form is the easiest one. I just got to make a true statement for 2 equations. So let's go 3x plus, let's go 4y. And all I'm doing is, what I'm doing mentally here is I'm going 3 times 5 plus 4 times 7. What does that equal? So I need this to be a true statement. So 15 plus 28, right? 15 plus 28, 43. So that's the first equation. So this has to be a true statement. So if I put in 5 and 7 into this equation, it'll be 43. And I can choose any x value. So let's go with, this time I'm going to go negative 2x plus, it doesn't matter what I choose, 3y. Okay, so I'm going to plug in again. So I'm going to get negative 2 times 5 plus 3 times 7. And so that number is 21 plus negative 10, so it's 11. And there's a good solution. All right, special combinations. It's a story problem, so you can do RREF once we get our equation set up. Strongly recommend that. There's special combinations, standard form, so 3x plus 2y here, they make 21 points. And they have a total of 8 baskets. And then so you do RREF on a matrix that's going to look like 3, 2, 21, 1, 1, 8. If you do RREF, again, that's in math matrix, the matrix math, I should say, you'll end up getting, I think it's 1, 0, I think it's 8 and 5, if I remember. And so that means your answers, 8 3-pointers, 5 2-pointers. The next one, 7b here, I wouldn't suggest RREF because it's not going to be in standard form. You could. It's not going to be nice numbers, but the only thing we really want here is the x value. I don't really need to know the y value. You could. The y value would just tell you when they're actually equal. So you have 2 jobs. Job A, and it's $8, and then it has 25 grand is a base pay. The other one is paying you more in commission, but you have less of a base pay. So, eventually what's going to happen, you have one that's up here, not as steep a slope. The secondary one, less initial pay, but eventually overtakes it. So the question that, and there'd probably be a follow-up question on your test, but like, which one should you choose? So there's this point where they're equal. So at this point, they're basically the same job, but if I'm going to only sell like down here, then I'd want the red one because I want more. If I'm over here when I'm selling stuff, I'm going to want the blue one because I'm going to make more. So you set them equal to each other and solve. So you get 25x plus 12,000 equals 8x plus 25,000. If you solve this, you're going to subtract the 8x across, and you get 17x, and the other side is going to be equal to 13,000. There's my 13, so I'm subtracting that 12,000 across. And And so now if I divide those, it's like 764 and change or something like that. 764 and change. So 764, the one's a little bit better, and 765, the other one's a little bit better. Okay, Cramer's rule here. Remember, you're setting up the matrices. So you've got matrix A, and you get, that's 4, 3, 5, negative 2. Matrix A sub x, you're replacing the x values with the total values. I think that's a negative 2, yeah. And then matrix A sub y, now I'm replacing the y values with the 16 and 2. So, like so, 16 and negative 2. And so we're going to, Cramer's rule says the determinant of A x over A, the determinants of each of these, that'll equal x. And same thing with A sub y on that. So if I do the determinant, remember it goes like this. It goes negative 8 minus 15. So it's going to be negative 8 minus 15. So that determinant is negative 23. This one here is negative 32 and 6 minus 6. So that's negative 38. So that makes x equal to negative 38 over negative 23, which the negatives cancel out. And likewise here, negative 8 minus, not a negative 2. I knew the answer was wrong. This is not supposed to be a negative 2. It's just 2. I'm like going, that's not right. All right, so let's do it again. So 8 minus 80 is negative 72. So that makes 72 over the 23. So you just, so in this case, it's a fraction. Just leave it as that. If it's not, if it's a whole number, great. All right, area of the triangle. So area of a triangle, one of the cool things about this matrix, it's going to be a 3 by 3 matrix. We're going to do the determinant. Remember, it's 1/2 the determinant, and it's the absolute value. So meaning that if I put this in this way in my calculator, that I'm going to get a negative when I put this in my calculator. It's okay. You can just ignore the negative because it's the absolute value. And if I do the determinant on that, I think you end up getting like, take half, I think you're going to get 11.5 if I recall. Maybe it's a 10.5 or something. But it's something like that. So I believe it's 11.5. My memory serves me correct. So you're just going to do that matrix math on your calculator. Remember, it's going to be a 3 by 3 matrix because there's 3 rows, and then there's 3 columns. So that's why it's a 3 by 3. These ones are there because setting ourselves up for a what's called a vector, and that's how it's all set up. All right. And Gauss elimination. This one is, of course, the daunting task to not screw up. It's to know what to do is one thing, and to do it, though, is another. So I'm going to go negative 2 times row 3 plus row 2. This one, remember, in class, it was actually easier than normal. And this is going to give me a new row 3. So when I do that, I do that over here on the side. So it's going to be, so my row 2 is 2x minus 3y plus z equals 4. And so I'm going to get negative 2x, negative 4y, negative 4z equals negative 30. And it's a negative 30. Add them together, the x's cancel, negative 7y minus 3z. This is my new row 3. And I'm going to do the next one, which is to get rid of the 2x here. I'm going to use, so this bottom row 3 is here. Okay, I'm just sort of short on space here. So negative 2 times row 2. I'm going to use row 1. Okay, and it's going to give me a new row 2. This is a little bit easier because both the x's and the y's are going to cancel out. So I'm going to go ahead and, so I've got, again, that's row 1 I'm using, which is 4x plus y plus 2z plus 22. And then I've got negative 4x, I believe that is now 6y. Minus 2z equals negative 8. So I'm taking this entire row and multiplying by negative 2. Add them together, these cancel out. And this cancels out too. Didn't intend for that, but it just sometimes does happen. And so now y is 2. So now that I know y is 2, I can go back and plug it into the other equation. So right here, so we've got negative 7 times 2 and solve that equation. So I'm going to get, there's negative 14, so I'm going to add 14 across. So negative 3z equals negative 12. So z is 4. Now I'm going to go all the way back to the very top here, or one of the original equations. Doesn't matter. It honestly does not matter which one I use, but because they're all going to be a true statement. So 4x plus y, that one. So 4x plus y, using the top equation. Well, y is 2, plus 2z. Well, z is 4, equals, I think it's 22, isn't it? 22. And if I solve for x, I'm going to get 12, because you're going to get 10 here, so subtract 10 across. So x is 3. So I've got 3, 2, 4. There's my order triple. All right. Good luck.